Okay, in this next piece of the chapter, we're going to look at the conversion of moles to atoms and molecules, or from atoms and molecules back to moles. This is the first conversion out of the mole unit that we spent a lot of time in class today in our discussion learning about and getting a basic understanding of the mole unit. Just a reminder, the mole is a number counting unit. It just tells us how many of a particular substance we have. It's very, very similar to the unit dozen. If you have the unit dozen, 1 dozen of something is 12. Well, a mole works the exact same way. 1 mole of something is just a very large number, 6.02 times 10 to the 23rd. It could be atoms, it could be molecules, depending on whether you're dealing with an element or a compound. That number, 6.02 times 10 to the 23rd, is an important number to have memorized for this course and is known as Avogadro's number. And we can now use that mole to compare any two compounds or elements in terms of mass, number of particles, concentration, and a number of other conversions that we can do once we get to balanced equations. So let's look at examples. We're going to go through a couple of examples of this just to make sure we reinforce it. And if you're ever stuck on a mole problem, I highly recommend that you take the time to think about how you would do it if we're asking dozens instead of moles. If you can figure out how to do it if we're asking dozens instead of moles, just replace the 12 with 6.02 times 10 to the 23rd and the 1 dozen with 1 mole, and you'll have your correct setup. With each of these problems, I recommend, as always, that you pause the video, try the problem yourself, and then press play to watch the correct answer. So this first one, we have 3.86 moles of sodium. We always write our starting value. Then we're going to have our conversion factor. Remember, in our conversion factor, the unit we want to cancel goes on the bottom, moles of sodium. The unit we want to find, atoms of sodium, goes on the top. We know from the relationship mole, 1 mole is 6.02 times 10 to the 23rd atoms. So we'll multiply by the numbers on the top, divide by the 1 on the bottom. So 3.86 times 6.02 times 10 to the 23rd. Keep the 3 significant figures from our original number. So 2.32 times 10 to the 24th atoms of sodium. Okay, the next problem. How many molecules of copper 3 chloride are in 0.274 moles? So we have 0.274 moles of CuCl3, copper 3 chloride. We're going to convert that into molecules. 1 mole goes on the bottom because that's what we're trying to cancel, is equal to 6.02 times 10 to the 23rd molecules of copper 2 chloride. 0.274 times 6.02 times 10 to the 23rd gives us, to 3 significant figures, 1.65 times 10 to the 23rd molecules of CuCl3. The only difference between this and the last problem is now we had a compound, copper 3 chloride, as compared to an element. So we were dealing with molecules instead of atoms. Next problem is the reverse of what we were doing before. This time we have 3.75 times 10 to the 24th atoms of aluminum. We want to cancel atoms of aluminum. We want moles of aluminum. 1 mole will be 6.02 times 10 to the 23rd atoms. So now we're dividing by 6.02 times 10 to the 23rd. Keep the 3 significant figures from our original number, and we get 6.23 moles of aluminum. This next case, we have molecules of water. 1.2 times 10 to the 22nd molecules of water. We want to get rid of molecules, so 6.02 times 10 to the 23rd molecules of water over 1 mole of water. And this time we get 0.0199, which would round to 0.020 moles of water. So 0.20 moles of water. One last problem that's a little bit more complicated. Now we have 2.56 moles of iron 2 chloride, and we want to know how many atoms of chlorine. So there's 2.56 moles FeCl2. We're going to convert this to chlorine. So for every 1 mole of iron chloride, iron 2 chloride, we would have 2 moles of chlorine. It's FeCl2, so when you break it apart, it forms Fe2 plus and 2 Cl minuses. So for every 1 mole, one of these whole molecules, you get 2 of the individual chlorines. So there would be 2 moles chlorine for every 1 mole. Then we can go 1 mole chlorine for every 6.02 times 10 to the 23rd atoms chlorine. So 2.56 times 2 times 6.02 times 10 to the 23rd gives us 3.08 times 10 to the 24th atoms chlorine. If we had done atoms of iron, it would have been a 1-to-1 ratio in this middle step here. We would have had a 1-to-1 ratio, and we would have gotten half the answer that we got, about 1.56 or 1.56, 54, 1.54 times 10 to the 24th atoms of iron. Okay, so when you're doing these conversions, I think it's very helpful to remember that the relationship is just the same as the relationship of dozens. 1 dozen is 12. 1 mole of anything is 6.02 times 10 to the 23rd. This last problem is about as hard as these type of conversions can get.